What is normal force? Normal force. Well, normal force is something that sort of prevents you from, I guess, falling through tables, falling through the ground. It's a force that is acted upon per the Newton's third law of motion. And also, I'll explain normal force using the laws of motion. But first, let's draw a table. And let's say that this table has a book on it. Say Diary of a Wimpy Kid, edition 1. And this book has a weight. So that weight is represented by W. Say it's 10 newtons. Ooh, this is a very heavy book, actually. And the table, per the Newton's third law of motion, must exert a force back up onto the book. So the force of gravity is pulling the book down, and that book is applying a force to the table. But Newton's third law of motion states that when you apply a force to something, it applies a force back in equal in magnitude but opposite in direction. So this force will be equal in magnitude but opposite in direction. And this would be the normal force represented by N. So if we draw, let's move the 3 here. If we draw a book in a less cluttered system, and I were to represent all the forces going on here, you would see a normal force and a weight force. And look what happens if we remove the normal force. Well, if you remove the normal force, what happens? Well, look at Newton's second law of motion. So Newton's second law of motion is force is equal to mass times acceleration. Well, more specifically, net force. So net force is equal to mass times acceleration. And you don't really need to worry about any other forces because, well, the only force acting on this book, if there wasn't a normal force, is the weight force. Let's draw the table again, I guess. And if this was the case, well, stated by Newton's second law of motion, this book would be moving downward. It would be accelerating downward. And let's say, I don't know, the mass is some example, 5 kilograms, right? And the weight force is 10. Then that means that force, so net force divided by mass, so I'm going to derive an equation. So if I divided mass on both sides here, then you would get this equation over here. So if we were to divide the net force, 10 newtons, over the mass, 5 kilograms, I would get an acceleration of 2 meters per second squared. And that doesn't make any sense because the book isn't accelerating. It's at rest and it's still. So without the normal force, well, the book would be going straight through the table and it would be flying into the center of the earth. But that is actually not the case here. And matter of fact, in real life, the actual diagram has a normal. I'm just going to erase it all, whatever. The actual diagram in real life has a normal force acted on the book that prevents it from falling through stuff. So this is the weight and this is the normal force. So look what happens here. If these two forces are opposite direction and equal in magnitude, that means the net force is equal to 0. And no matter what the mass is, let's say 5 kilograms in this case, so 5 kilograms, the acceleration must be 0. Because if you divide 0 newtons by 5 kilograms, well, that still equals 0 meters per second squared for the acceleration. And that makes sense because this book isn't actually moving at all. So the normal force just prevents this book from falling through the table and plunging straight to the center of the earth. And another key point is that the normal force is nearly always, almost always going to be perpendicular to the surface. So if the surface is a table that's straight across, the normal force is going to be perpendicular. It's going to make a 90-degree angle with the table. But if, let's say, you're in an inclined plane and you have a box again, you have a book, Diary of a Wimpy Kid, edition 1, then the normal force will point perpendicular to the plane as well. And I'll teach you how to solve for that in other videos. But, as always, if you have any questions, put it down in the comment section. Thanks for watching.